All right, let's look at today's material, which involves um, solving linear inequalities. So we've looked at solving equations, linear equations. Linear just means the power is one of your letter. Um, so we're going to look at inequalities. So what are inequalities? Inequalities are less than, greater than, less than or equal to, or greater than or equal to. Those are our inequality expressions. And so before we get into solving them, let's talk a little bit about graphing inequalities. So if I wanted to graph an inequality, if I want to graph all the numbers greater than 3, there's two ways I can graph it. And in this class, what I don't want you to do is, we're going to do it on the number line. And so when I draw the number line, what I don't want you to do is do like 0, 1, 2, 3. I don't want you to do that. I just want you to label the number we're looking at, 3. So we're going to do this two different ways. And when you're doing your homework, you just do it one of the ways that you feel more comfortable with. But you should know both. You should know both. So one technique of how to draw this set of numbers that are greater than 3 is you put a circle on that end number, that 3. And then we're going to go every number greater than 3. So we're talking about 4, 5, 100, 7 million, also 3.1, 3.25, all that. So on the number line, what that indicates is everything to the right, everything to the right. Now, what I'm not going to do is I'm not going to shade the number 3. I'm not going to shade the circle because 3 is not greater than 3. So I'm going to leave that circle unshaded. And in fact, sometimes people will come in and they'll just kind of, oops, I guess that's kind of a bigger than I intended, but they will, just have a clear circle, not even the little notch there. But it's fine if you have the notch. I'm not going to worry about that. All right. A second alternative is same idea. We're going to go to the right, but this time instead of a circle there, we're going to put a parenthesis on the 3. And the parenthesis means the same thing as the open circle, the circle that we did not shade in. It means that every number bigger than 3 in this case is going to work, but that end number, that boundary number 3, is not going to work. That's what the parenthesis. It's kind of, think of this as like a flexible shape. You can get close to it, 3.1, 3.01, 3.001, but you can't actually touch 3. It always will flex away from you. And so that is how you indicate if you want to use that type of notation. But again, you can use open circle if you'd rather do that. Let's compare that to x is greater than or equal to 3. So how is that different? How is that different? And again, we're going to graph it two possible ways. And again, you don't have to do both ways. You just do one of them. But again, we're going to label 3. And we're not going to worry about 0, 1, 2, 3. Just label 3. The reason why is because we might work with numbers that maybe it's not easy to scale in. If I'm saying, hey, where's the square root of 2? That's like 1.4 something. It might just be easier just to label square root of 2. Likewise, you might go up to like 400, and you're not going to count off up to 400. So we're just going to label the number that matter, or numbers if we have more than one number. All right. All right. So let's say I decide I want to use circles here. I want to use circles. So this says I want all the numbers, x represents all the numbers that are greater than or equal to 3. Well, again, just like above here, greater than 3, that was all the numbers to the right. So we're still going right in this case because we're still talking about greater than. But in this example, it also says or equal to. That's what this little underline means here is or equal to. This is greater than or equal to. Okay, whereas this one is just greater than. We say this is a strict inequality. Greater than. All right. So this is greater than or equal to. So since it's or equal to is an option and 3 is equal to 3, we're going to go ahead and shade in that circle as well. Remember, we're shading every number that works on our number line. Well, this time 3 does work. 3 is greater than or equal to 3. Now, how do I indicate that if I don't want to use the circles, well, I put a bracket there. I don't use a parenthesis. Remember, parenthesis indicates that the end is not included. In this case, the end is included. 3 is an answer in the solution set of numbers. So I'm going to shade everybody above 3, and I'm going to put a bracket on 3. Some people like the circles better because you don't have to decide if you're going left or right before you get started. But you'll notice a lot of textbooks will use the brackets and the parentheses. So you should know both. You should know both because you don't know in the future what people are going to use. And so you should understand how those match up. So these mean the open circle and the parenthesis mean the end is not included. Okay. And the solid dot and the bracket mean the end is included. Okay. So keep those straight. Keep those straight. All right. Now let's talk about solving equations. And for each of these, we're going to solve them and we're going to graph. So we're going to solve and graph. Well, actually, these problems. So in order to do that, let's talk about some properties. So the first property we're going to talk about is the addition property of inequalities. All right. And so what this says is if A is bigger than B, if A is greater than B, then if you add something to both of those, that relationship stays the same. You know, if Alan has more money than Barry, then if we give each of them $100, Alan is still going to have more money than Barry. Okay? Likewise, if we were to subtract the same amount of money from both of them, you know, if Alan has more money than Barry, then if we take $100 from Alan and we take $100 from Barry, Alan's still going to have more money than Barry. Or if A is less than B, and it's the same idea. If you subtract or if you add something to both of them, if Ann has less money than Betty, then if you give both of them $100, Ann is still going to have less money than Betty. Or if you take $100 away from both of them, Ann is going to have less money than Betty. So, you know, that's still true. This is just like when we did equations, except that you're looking at an inequality. By the way, all these properties work for greater than or equal to or less than or equal to. The or equal to does not change how these work. All that changes is whether when you get your answer, if that value itself is also one of the possible, that end point, that end number is one of the possible answers. Okay, so let's look at solving and graphing. So solving and graphing. And let's say we were given a problem. X plus 7 is greater than 5. And I want to solve and graph that. So just like we did with equations, what I'm going to do is since I'm adding 7, I'm going to subtract 7 from both sides. Those 7s are going to cancel out. I'm going to get X is greater than 5 minus 7 is negative 2. And now I'm going to graph that. I'm going to graph that on the number line. Negative 2 greater than means that direction. Again, you can use an open circle if you'd rather do that, but this is how it'd be in the book. So I'm just going to follow the book's symbols, but again, you're welcome to use circles if you'd rather do that. Now, if you check your answer in the back of the book, what you'd find is that's not actually how they write their answer. The way they write their answer is like this. This is called set notation. So the little braces here, the little squiggly braces, they mean the set of numbers. So these are the set of numbers, X, such that this is true. That's why this is called set builders, because you're using a rule to build the set. So the rule is the number has to be bigger than -2. You do not need to put all of that stuff on your homework. I'm fine with you leaving it off. I just don't want you to get confused when you look in the back of the book and you see that they kind of fancy it up a little bit. Just understand what they're saying. They're talking, this is a set of numbers. It's not just one number, it's a set of numbers. And those set of numbers follow this rule. All right, let's try another one of these. Let's say I have, what should we do? A minus 3 is less than or equal to 4. So I want to solve that. So again, just like before, I'm going to look at my variable. I'm going to look what's with it. I'm going to get rid of that -3 by adding 3. So always think of the opposite operation here. And so that's going to give me A is less than or equal to 7. And again, if you want to, you can fancy that up. You don't have to, but the set of numbers such that those, oh, and I should put this in some A, because that's our variable. A such that A is less than or equal to 7. So when I go to graph that, I'm going to draw the number line. I'm just going to label 7. Don't label all the numbers, just label the number we care about, that endpoint. This time we're going less than or equal to. So or equal to means we're going to use a bracket, and less than means we're going to shade over here to the left. And make sure I can look at that, what you're doing, and I can tell which side you shaded. You know, if your left and right hand sides of your number line are the same kind of thickness, then I'm not gonna know which way you go. So go ahead and make it clear which way we're shading for the answers. All right, let's try another one. This time, let's say I want to solve and graph 12 is greater than B plus 4. All right, now we're going to be a little bit careful about this. We're going to start with it just like we normally would. We're going to look at our letter. We're going to say that 4 is with it. I'm going to subtract 4 from both sides. All right, 12 minus 4 is 8. I'm just going to drop this symbol down. I'm not going to change it. And then B, right? And the 4's cancel out. Now, how you would read this as it's written is 8 is greater than B. That's not really how you want to look at these. What we want to do is we want to switch this around into, instead of saying 8 is greater than B, we want to say B is less than 8. That's the order we want to put it in. We want to flip it around and put our variable on the left-hand side. So just kind of keep in mind, this is kind of like the alligator mouth, chomp, 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 right? So my alligator wants to eat the 8. When I flip it around, that relationship should stay true. My alligator still wants to eat the 8. So if you flip it around and suddenly your alligator decides he wants to eat the other one, then you didn't flip it right. And then again, if I want to fancy this up, the set of numbers B such that B is less than 8, draw your number line, less than 8. So I'm going not including 8. Right? It's not less than or equal to. So I'm going to put a parenthesis there, and I'm going to go that direction, less than. So watch out. If you end up with your letter on the right-hand side, you're going to have to do a visual rotation probably. Now, you could leave it this way as long as you understood you were reading it from the direction of the B. B is less than 8. If you can read it that way and graph it correctly, fine. But if you think there's a chance you're not going to get it graphed correctly, then I would say go ahead and move it around the other way, okay? Move it around. So let me take my little alligator teeth off of here. But rotate it around so that your letter is on the left-hand side. All right, pause this video and do the first set of problems and then come back. So, okay, so assuming you did the first set of problems, let's move on to the second set of problems. And the second set of problems are going to deal with the multiplicative property of inequalities. And you're going to find this is a little bit more complicated than it has been in the past, unfortunately. So let's say A is greater than B. Then if you multiply both of those by a number, you will keep the same number if C is positive. So if you multiply both sides of your equation by a number, you're going to get the exact same kind of relationship you had that at the beginning. Likewise, if you were to divide both sides by a number, again, you would have the same type of relationship if C is positive. And if it's positive, that means it's not zero. So I don't need to say you can't multiply both sides by zero. That's still true. Or you will get, so these kind of go together, right? Or if you multiply both sides by C, this symbol will change if C is negative. Again, if you divide both sides by a negative, that's also changed. So notice in the original expression, we had a greater than, and when we multiplied by a negative, it switched to a less than. Switched to a less than. Okay? Whereas if we multiply by a positive, it stays a greater than. So this is a little trickier. This rule is trickier than it is for equations. Because of this whole multiply or divide by a negative, you're going to flip the sign. Likewise, I'm just going to say likewise for A less than B, right? If you multiply both sides by a positive, you're going to keep the relationship. And that includes divide, right? That includes the dividing. Or it'll switch around if C is negative. Okay, so the big thing is if you multiply or divide by a negative, not add or subtract. Remember, we already did the adding and subtracting thing, and if you add or subtract, that's fine. Nothing changes. But when you multiply by a negative, what you're saying is I want the opposite of what I'm looking at. So if you multiply by a negative or divide, because that's really just multiplying by a fraction. If you multiply by a negative, you're saying I want the opposite relationship. So if your relationship was originally greater than, the opposite of that would be less than. If your original relationship was less than, then the opposite of that, if you multiply by a negative, would be greater than. So you're going to do this kind of flip-flop sign thing. So let's look at some of those problems. So again, we're going to go solve and graph. All right, so let's say I have 3x is less than or equal to negative 18, and I want to solve that. So what we've done in the past is we said the coefficient of the x is 3. Anytime you want to separate the coefficient from the variable, we're going to divide. So we're going to divide both sides by that number 3. So I'm going to come over here and divide by 3. 3 divided by 3 is 1. X is less than or equal to. The number I divided by was a negative, so this symbol does not change. And then negative 18 divided by 3 is negative 6. Again, you can leave it like that, or if you want to fancy it up, you can do the whole x such that, and then I'm going to graph that. Negative 6. It's including the end because it's less than or equal to, so we're going to put a bracket on the end, and then less than means going this way, going to the left. Let's compare that to negative 4x is greater than negative 16. I want to solve that. So I'm going to divide both sides by negative 4. X is, because I divided by a negative this time, this is going to switch that inequality. So it doesn't have anything to do with the or equal to. That's not why we switched it. It had to do with the fact that we were dividing by a negative. The thing we were dividing by was a negative. Doesn't matter that the other side was negative. That doesn't mean anything. It matters what we were dividing by. And so that is a positive 4. And so I'm going to draw the number line. 4 is not included, so I'm going to put a parenthesis on that and go in that way. Okay. All right. Let's try another problem. Let's say we have 20 is less than negative 3x. Okay, so I want to solve that. I'm going to look at my x. Negative 3 is with it. They're touching. So to get rid of it, I'm going to divide negative 3 on both sides. So this is going to come out to be negative 20 over 3. Because I divided by a negative, my inequality symbol is going to switch, and I'm going to have x. Now, again, we could graph it in that format, but it's probably better to go ahead and switch it around, put x on the left, but notice your x has the bigger side pointing at it. So when we rotate this around, that bigger side still needs to point at it, okay? So make sure you rotate that symbol as well, negative 20 over 3. And then I'm going to draw that. Where is negative 20 over 3? Well, negative 6 2/3, or you can just say negative 20 over 3. This is why I said we only want to label the number that matters. We don't want to label every number. Just label the number that matters, and we're going greater than, so we're going to the right, but we're not including it, so we're going to put a parenthesis on that end there. Okay, so, but we're going everywhere to the right. That's supposed to be an arrow. Okay, all right. So watch out when you're multiplying or dividing by a negative that you change that symbol there. Okay, pause this video, do the second group of problems, and then come back. All right, so assuming you did the second group of problems, let's move on to the third group. Now, I want you to graph these as well. These are general equations, so we're going to look at a few of these, just kind of remind ourselves how to solve general, well, I guess inequalities in this case, but we're still going to solve and graph. Okay, so let's say I have 3x minus 11 is greater than 5x plus 4. Okay, so let's say I want to solve that problem. And we say first step, simplify both sides. Got that done. Second step, get it so that there's only variables on one side. So we need to get rid of one of these variable terms. And normally I would say, let's get rid of the 3x so we would get a positive coefficient. But because we're going to want to flip-flop, we're going to want to end up with a variable on the left-hand side anyway. And we may not want to do what we just did on this previous problem where we figure it out and then we rotate it. We might just want to always move things to the left in this case, and just kind of save ourselves that trouble. It's going to cause other things to happen, but in the long run, it's probably going to save us a little bit of work. So I'm going to get rid of this 5x on the right-hand side, which means I need to subtract 5x to get rid of the whole term. 3 minus 5 is negative 2x minus 11 is greater than 4. Right? The 5x minus 5x, those go away. All right, now I'm solving for x. So we said the next thing you want to do when you only have one variable is get rid of the constant term. So I want to add 11 to both sides. That'll get rid of that constant term for me. Negative 2x is greater than 15. And now get rid of the coefficient. In order to get rid of a coefficient, we do that by multiplying or dividing. In this case, we're going to divide by negative 2. Because I divided by a negative, my inequality is now going to switch to a less than. It went from a greater than to a less than. It switches direction. Okay, and then this, what is this? Negative 15 halves. That's what that is. Again, negative 7 1/2, but I would just say negative 15 halves. Don't do more work than you have to do, so you don't make a mistake on accident. So less than means a parenthesis, and we're going to the left. Left there. All right. Okay, let's do another one of those. Let's solve and graph 2/3 x plus 4 is greater than or equal to 1/5 2x minus 5. Okay. So first step, we want to clean up both sides, simplify both sides. So we're going to need to take this 2/3 times x and 2/3 times 4. So that's going to be 4 over 1. So this is going to be 2/3 times x, it's just 2/3 x, 2/3 times 4, 4 over 1. So top times top, times bottom is going to give us 8/3. Greater than or equal to, again, this is 2 over 1, this is 5 over 1. So top time, we're going to distribute this one. So top times top, 2, bottom times bottom, 5. So 2/5 x, top times top, bottom times bottom. So 1 times 5 is 5, 5 times 1 is 5, 5 divided by 5 is 1. All right. And then we're going to solve this problem. So again, we only want x's on one side, so I'm going to go ahead and subtract 2/5 x from both sides. And again, you don't have to do fractions by hand. You can use a calculator to do it, though you should know how to do fractions by hand. Find a common denominator, that would be 15. That's where they match up at. And then figure out what do you need to multiply the top and bottom of this to get 15 on the bottom, and that would be a 5. So this is 10/15. This one you have to multiply top and bottom by 3. So that would 3 times 2 is 6/15. Subtracting 10 minus 6, 4/15 x plus 8/3 equal, or not equals, greater than or equal to. Don't switch into equal signs. We're so focused on the little details that we might lose the fact that we're doing inequalities. Don't do that. -1. Don't lose the negative with the 1. And now I'm going to solve for x. So I'm going to get rid of this 8/3. Again, you don't have to do that by hand. If you want to use a calculator, that's fine. But again, you should take it as a point of pride to know how to do it. So common denominator, this is 1 over 1. The common denominator would be 3. So this is going to be -3 over 3, -8 over 3. Putting those together, -3 and -8 make -11 over 3. And now I want to get x by itself. I'm going to divide both sides by the denominator, or by the, not the denominator, the coefficient here, which is 4/15. Just a reminder, you don't divide fractions. What you do is you keep the first one the same, you change the multiplication, and you flip the second one. You multiply by the reciprocal. So notice 3 goes into 3 once, and 3 goes into 15 5 times. You can do that top times top, bottom times bottom, 11 times 5, -55 over 4. So that's going to cancel out. So what do we have? We have x. We divided by a positive, so our inequality is going to stay greater than or equal to. And then on the other side, we figured out the other side works out to be -55 fourths. And again, you don't have to do that by hand. If you're going to use a calculator, I would suggest putting these in parentheses if you want to use a calculator, just to be safe. Make sure the calculator does it the right way. But we get this. Where is that? What? 13 3/4, -13 3/4. Again, it doesn't really matter. Just draw the number line. Just label -55 fourths, and then greater than or equal to. The or equal to means use a bracket there. The end is included. That is a possible answer. And then greater than. So we're going to go to the right. And there we go. And again, just a reminder, if you want to, fancy that up, you can do the whole set notation, the numbers such that those numbers are greater. Again, I don't require you to do that, but don't get thrown off when you see it on a test or in the back of the book or something. They're just talking about a set of numbers, so they use that set notation. All right, so that is the content for this section.